SOLAS for Missing Data Analysis version 4.0 Mahalanobis Distance Matching Method example video. We will now multiply impute all of the missing values in this dataset using the Mahalanobis Distance Matching method. From the Analyze menu, select Multiple Imputation Mahalanobis Method. The Specify Mahalanobis Method window is displayed. The window opens with two tabs, Base Setup and Advanced Options. The Base Setup tab allows you to specify which variables you want to impute and which variables you want to use as covariates for the calculation of the Mahalanobis distances. Drag and drop the variables to be imputed. In this case, measure 1, measure 2, measure 3, and you can also hold the control button to select several variables at the same time. Drag and drop the covariates into the fixed covariate fields. Again, several variables can be taken at the same time. As there is no grouping variable in this dataset, we can leave this field and the center variable field blank. When calculating the Mahalanobis distance between two cases, the selected covariates will make up the vectors used in the calculation. The non-monotone and monotone tabs allow you to add or remove covariates from the logistic model used for inputting the non-monotone or monotone missing values in the dataset. You select the plus or minus signs to expand or contract the list of covariates for each imputation variable. Variables can be added or removed from this list of covariates by simply dragging and dropping the variable from the covariate list to the variables field or vice versa. Even though a variable appears in the list of covariates for a particular imputation variable, it might not be used in the final model. By default, all the covariates are forced into the model. If you uncheck a covariate, it will not be forced into the model, but will be retained as a possible covariate in the stepwise selection. The donor pool page allows more control over the random draw step in the analysis by allowing the user to define the Mahalanobis distance subclasses. The following options for defining the Mahalanobis distance subclasses are: use See Closest Cases. This option allows you to specify the number of closest cases that are to be included in the subset. The other option is the use D% of the dataset closest cases. This option allows you to specify the number of cases as a percentage. When you use a refinement variable, the program reduces the subset of cases included in the donor pool to include only cases that are close with respect to their values of the refinement variable. You can also specify the number of refinement variable cases to be used in the donor pool. For this example, we will use all the default settings in this tab. The Advanced Options tab allows the user to control the settings for the imputation. The main seed value is used to perform the random selection within the Mahalanobis distance subsets. The default seed is 1, 2, 3, 4, 5. If you set this field to blank or set it to 0, then the clock time is used. The output log is a comprehensive list of regression equations, etc., that have been calculated for the imputed variables. The value set in the tolerance data field controls numerical accuracy. The tolerance limit is used for matrix inversion to guard against singularity. You can select F to enter and F to remove values from scrolled data fields, or enter your chosen value. If you wish to see more variables entered in the model, set the F to enter value to a smaller value. The numerical value of F to remove should be chosen to be less than the F to enter value. Selecting impute non-monotone values by Mahalanobis distance will force the system to use the Mahalanobis distance method to impute all values, whether they are in a monotone or non-monotone pattern. Once you are satisfied with all the selected options, click OK and SOLAS will perform the multiple imputations. SOLAS has now imputed the missing data 5 times, with each imputed dataset appearing in a separate tab at the end of the screen. The values in red are shown in the monotone pattern, while the values in light blue are non-monotone values.